I want to make an announcement that Ryan Vandermeulen and I are running a fisheries-focused PACE Hack Week. When I say fisheries, that could be, phytoplankton. No, that is phytoplankton, halves, ocean ecosystem, anything like that. It's a virtual Hack Week. It'll be at the end of October. And it'll be kind of like this one, but virtual with hack sessions either in the morning or the late afternoon to accommodate different time zones. If you're interested, I'll post this in the Slack, and I'll announce it in the Slack. So you can look at that and check it out. All right, so let's go here. All right, so our time here is rapidly coming to an end. And so we want to talk a little bit about what comes next. How do you kind of launch forward when you are leaving here and then say you need to create your own compute environments for doing your work. And so this is all in the rubric of reproducible research. So I'm going to be discussing it in that context, but we kind of think of this also, as I said, this kind of fledging. You're not here, we are in this environment that we've created. What do you want to do when you want to move forward? All right, so let's talk a little bit about reproducible research and what that term means. And I think of it as kind of two things. First off, it's a gradient. There isn't like, oh, you're perfectly reproducible or you're not. It's very much a gradient. And if we think about our code base, that's around how we share our code with our colleagues, with the outside world, how well things are documented, how well someone else can take our work, our code, and go and do understand what we did, and then do something new with what we've done. Then there's the workflow. And this is kind of gets into the area of what is reproducible science? How do you create reproducible science products? I work for NOAA Fisheries. I'm in charge of running workforce training around improving our reproducibility of our work. We create these big reports, big teams, and at the end of the day, after you create something big, it could be also like a paper, a research publication. How can you do that work so that you can reproduce it later? And that gets into this workflow idea. And for your workflow, yes, written methods, points of contact for each thing. That's something people often forget about. In a big project, you often forget about who made that graph? How did they make it? Documenting how you're working, and then as you get more reproducible, moving towards scripted workflows. So you're integrating your text and your data analysis, and it's one big script rather than having a lot of manual steps that you really can't reproduce. Okay, so I'm going to talk about if you take home anything about improving the reproducibility of your work, that's what I'm going to hit out. So I've already talked about using Git and how that's really important. You hopefully have gotten more experience with this. Then there's the part about writing code that is easier for other people and for yourself to use and understand. And that means taking your code that you've been munging and hacking at it and stepping back, cleaning it up, and turning it into a documented function that you can call. And this is a really critical piece, because one of the things that makes coding and large code bases, well, the kind of notebooks that you're creating that starts to make them really disorganized and in the end non-reproducible is that you have copies of the same or similar functions all over the place. So you keep copying it, and then you'll change it in one, and you'll change it a little bit in one, and then before you know it, it's a mess. Okay. So I think what I'm going to do here is, yeah. Okay. So I want to show you what this looks like, because I can talk about this, but then if you haven't seen it before, I'm sure it seems mysterious. So I want to get this, and so I'm in the Jupyter Hub here. Okay, right here. Okay, and I'm going to get to home here, and I want you to notice that I've got this file here called data prep, and it's the same place as my notebook. So there it is. All it is a little function. But imagine if you had all your functions in there, in whatever directory you're creating your notebooks, and then I have a notebook here, and ignore that. Okay. So now this thing is called data prep. I just imported it. And now I can do add 1, 2, 3. Okay? So it's that simple. Create a .py file with your functions in your repository, and not in your repository, in your directory with your notebooks, and then you don't have to keep copying those functions over and over again in your notebook. Okay. So I know that's old hat for those of you who have already been doing it, but those of you who are newer to Python might not have seen that. Okay. All right, so we have basic things about your workflows. So this line that I crossed out is, the advice that certainly, I was given, but I've come to learn is bad advice. Because it sounds great, yeah, document and share your code and data upon project completion. Yes, absolutely do that. The problem is that if you tackle that task upon project completion, you are never going to do it. You're just not. Even if you desperately wanted to, it would be very hard for you to go back and document everything. You will have forgotten so much of it. Yeah. And, sure, that's nice. It keeps the track of the commits that you're making along the way. But that by itself is just going to be, not very useful. It's useful for lots of other things, but it's not useful for documenting your workflows. So to get a reproducible workflow, you have to change the way you work. And so here are some of the key changes. One is working with smaller blocks of task. If you take a big task and then you approach it by just chipping off things like month after month, that's really hard to document. If you work in smaller chunks and say, hey, today I'm doing this task, I will complete this task and record what I've done, and then I'll turn to the next task. Working like that allows you to start to do these things that are critical. So one, at the end of the day or end of it's not a day or a couple days, you do some cleanup. So it's normal that you're just going to have lots and lots of files and your code is a mess, but training yourself to spend a little time cleaning up at the end of the day. Don't leave all these files out there. Don't leave your notebook in a complete and utter mess with trying to remember, oh wait, what do I do? Okay, wait, no, I need to run this code, and then I need to go back to the top and run that code, and then run that code. Don't feel bad if yours looks like that. That's kind of pretty common for a lot of people. So you can slowly train yourself to clean up and put things in the right order. So when you come back the next day, it's cleaner. But more importantly, when you come back a week later, like tomorrow, you might still remember what you're doing, but a week later, you won't. And then secondly is at the completion of each chunk of work. I put weekly here, but I think for a lot of people, well, a lot of work has found like a bi-weekly chunk of work is a pretty good amount, like work hard for 2 weeks, and then really clean things up. Clean things up, like notebook is common, or scripts and notes, something, and really clean it up and say, hey, this is the part that I'm going to keep. And you can see here why it's important to break things into smaller chunks of work in order to do that. Because if you're breaking things into 6 months chunks of work, you can't do that completion step at a high enough frequency. Any of you who come from software development will kind of recognize this idea of having these like 2-week chunks of work. And then definitely doing this before you leave the project at any extended amount of time. But this middle part here, this completion, cleaning things up, documenting everything at these shorter regular intervals is really critical. Whenever, like I said, I do training for our workforce, and I'm not the most like disciplined person, so like this takes a lot of work for me. But I will say that it is possible to get better. And you think, oh yeah, I'm just like this. Well, yeah, but you really would be happier if you would, moved a little bit in this direction. And I really like this book, Atomic Habits, for like, if you're like, how do I get myself to stop doing that thing? And this has some really practical suggestions. You can also do Google that, and it'll give you the short paragraph version. And then I wanted to talk, just show you what workflow analysis looks like. And so this is kind of your daily workflow, or your just personal kind of workflow. But then for a large team, in order for them to create things that are reproducible, they need to be doing a large workflow analysis periodically. And this is an actual example from 2022 of a team. And that is getting a whole team together and spending some time outlining how they get to this report. So this is how all the things that are going in here, and getting some high team awareness about like what's happening with all these parts, who are doing these parts. Because oftentimes teams work very siloed. Like one team will produce something and they hand it off, but another team doesn't really understand what they're producing and what goes into that. And then if you never talk together, you create these just workflows that are not as good as they could be. So you're doing this kind of analysis, and then the whole team, by talking all together, they start to recognize or plan out, okay, what are the things we need to improve? And the reason especially that it's important for the whole team to be involved in this and kind of break down these silos, like once a year, or every 16 months or 18 months or so, is that there may be other teams that understand, like, oh, hey, this one here, the problems you're having here, we know how to solve that, and we can help you. Okay, so that's it for workflow. Okay, so let's go now we're switching gears. We're going to switch gears about 3 times in this talk here. Okay, so we're going to talk about reproducible compute environments. So at the Hack Week, you've been using an environment created by Ian. And so you've been using a Docker image. I'm going to talk a little bit about that and show you how to create that very quickly. Believe it or not, it's gotten way, way, way easier. But let's start off with these environments. So environments are important because they create a, well, we have all these packages that we're working with, and they can also depend on these system tools which these are all packages. It's not showing the system tools, but it's things like GDAL under the is like a system tools that the spatial packages depend on, and we need them all to play nice together and not have any conflicts, and that's a really hard thing. But fortunately, we have. Oops. I guess I'll have to go back here. We have these things called package managers that resolve any conflicts and create us a nice environment that is going to not have any conflicts. Conda is the one you hear all the time, although I think under the hood it's actually using Mamba now. Mamba's a lighter weight version. I think a friend was telling me that now when you say Conda, it's actually using Mamba. Regardless, they are package managers, and they do this the package solving, like when you set up an environment, it'll say, solving. Well, it's trying to figure out, do I need version yada, 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 or version yada, yada, and then it's doing this very complex solution for you. Okay, and why do we need to do this? Like I said, we need to make sure that they all play nice together, there aren't any conflicts. Why is this important for a reproducible environment? Well, packages change over time. So imagine you're doing something this year. You want to be able to record the environment, all the packages, all the versions and everything that you were working in, and when the code worked. And then a year later, 2 years later, you can come back, you could reload that reproducible environment. So yay, it would work. Also, what if you are going to have your colleague work with your code and you want them to use the exact same environment? So you give them the environment file and they can create that environment so things work. Okay, so let's see what this looks like here. Okay, so Conda environment. So this is a file that would specify what the dependencies are, the things that we want in our environment. So this is a very simple environment. We're specifying what version of Python, NumPy, Pandas, Xarray. This is a case where it's called pinned. We are specifying the versions. You don't have to, but we're showing them pinned so you can think about it being reproducible. You can hand that to someone and they're going to load it, install this environment, and they're going to get exactly those versions. Creating this is really easy. Nowadays, you can ask the chat bot about this or Google it. So just Conda environment create. You pass it that environment and then activate, and you're good to go. When you need to remove it, that's how you remove it. Okay, but I'm going to do a little demo for this. This is one of the questions we get the most. And that is how, this is for those of you who already use Conda. You're like, yeah, Eli, I know, I want to use this thing. And how on earth do I use it in this Jupyter Hub? All right, so you'll have these available for you. But I'm going to show you how it works. Please don't play along if you're tempted to play along. The reason is I'm going to create a kernel in the Jupyter Hub, and nothing bad will happen, but there's no reason for you to clutter up your Jupyter Hub. Okay, so here's what I do. Okay, so you notice these? I got this. This is about to change. Hopefully I can go back in time. Okay, because I don't want to have to type it. Okay. Come on. Okay, so here we go. I am going to create this environment, and the key thing is that, oh wow, that's tiny. Okay. The key thing to know on the Jupyter Hub, the Conda is created in the kind of the operating system files. Every time you start up the server, it wipes that out, and it starts with the one from the Docker image. So that if you just use Conda environment create, environment YAML like you normally would, next time you come on, you have to do that again, and again, and again, every time you start it up. And if you don't want to do that, many people don't, then what you need to do is create the environment in your home directory, because your home directory is persistent. And this is how you create it. We use this prefix, this -p, and you tell it where to put it. So I do that. Okay, it's going to be creating it. Okay. So it's going to create that. And then the next step, and this is really important in this step, is, oh, actually, I should go back here. I should show you something while it's solving that. Oh, wow. Okay. When you're doing this, you have to have this package called ipykernel. It is creating this is what is going to, you'll see it's going to create a little button that I can click to drop into this environment. Okay. So I'm here, it's still executing. Okay. That's okay. So how this works is that I need to create the environment, and then I need to do this kernel install. You may not have noticed it, but when you open a notebook up in the corner over here, you can select the kernel, and you are selecting the environment that you're in. By default, it's going to the one that has been created for you in the image. But if you want to get into your own, you would drop down and then select your own. Let's see if I can get through here. Ah, okay. Yeah, see, this is why you don't want to be creating this environment every time you have to start up the server, because this solving step takes a long time. All right. Yeah.
We kind of went into this little blind. I started installing libraries like in my sort of directory. And of course, inevitably ended up breaking things, and then realized I should probably create these environments.
Yeah.
So in this case, is it good to like maybe test it out first in sort of one of these environments, make sure everything works, and then sort of install the home directory, or is it not going to screw things up? I guess, can I break the home directory if I make a bad environment or something?
You can delete the environments, yeah.
Okay.
In fact, you can just delete that whole directory. Yeah.
Some libraries that just have.
No, yeah. So an interesting thing about the Conda environments is they are going to be installed all in their own directory. They're kind of this isolated thing, and the other Conda environment is going to be in a different directory. And when you activate an environment, what you are doing is you are changing your path. So it's pointing to binaries in a different directory. So you can look at that as you activate different directories, and then if you look at the path, you'll see that the path is changing. So, and that also, knowing that is how you can debug weird things. You're like, what is it not working? And then you look at the path and see if something bad has happened with the path. Okay, so now I'm here. If you look at this here is telling me what Conda environment I'm in. It's one telling me I am in a Conda environment. So path. So you can see, look at that. That is where it's pointing to that environment. So that's how it's pointing there. So it knows what environment I'm in. And let's go ahead and activate this one that I just created. And for creating kernels, this is a critical step. So let's do that. Now you see it's changed, so I know that I'm in that environment. Let's do path. And look at that. So now it's pointing to environment simple geo binary. So it is switched where it's looking for the binaries for Python and all those packages. And notice that the notebook-ins notebook bin is not on the path anymore. So that it's kind of, it seems mysterious activating environments, but really what's happening is it's changing your path. And then the next thing that you have to do, so now you've done that, and now you create the kernel. All right, and I go here, and I reload that. Oh, fine, come on, come on. Shut down all, shut down all, let's start back up. Okay, and now, there it is. So now when I click on this, yeah, come over here. See, it says simple geo environment, and I did not put Earth access in that, so if I do this, it's not there, because I'm in this new conda environment. Okay, that's it for that little detour. For those of you who are like, why is she talking all about conda environments? Then you can just kind of ignore this. But for those of you who need to have your own conda environment in a Jupyter Hub, it will be very, very hard to figure out how to do that on your own. At least I found it really hard. Okay, so lastly, I'm going to talk about these Docker images. So a Docker image, like the one that we are using, is instead of just having all the packages, it has all the packages and the whole system environment. So like the one that we are using here, Ian installed, all the, OCSWW something something stuff for you. And so you don't have to install that. And when you need to use a environment that's a bit more complex, then creating an image is the way that people will often do that nowadays. And then what we can do is we can be using this exact same environment and all our system libraries and everything. We can use it on our laptops. We can use it on Jupyter Hub. We can use it on our virtual machine anywhere. If we're like running, things, like you saw that gateway example where we're like spinning up a whole bunch of virtual machines. That is going to need the image. It takes a Docker image that it's sending off to all those virtual machines. Okay, so yeah, all these good things, the environment isolation. But that last example with the virtual machines is, I think, why I've been seeing a lot more people creating their own Docker images. It used to be pretty much a niche thing, but now you're seeing it much more commonly, and that's because people may need to spin up a virtual machine right next to the data. So let's say you have, there's some data set you want to use. They've got it in an S3 bucket in East 1. Our Jupyter Hub, and let's say they make you pay for the data. And you have to pay for the data if you're out of region. So if you're not in East 1. Well, our Jupyter Hub is in West 1, I think. So if you were to connect to that, and they make you pay, no, not West 2, yeah, so it's in West, it's not in East. So if you were to connect to that data and they're making you pay, unlike NASA, they don't make you pay, but say this other group did, then connecting to that from our Jupyter Hub, like that would be expensive. So instead, what you'd like to do is spin up a virtual machine. I don't know if Dask Gateway allows you to do that. No, I don't think Dask Gateway does, but does it allow you to specify the region?
Oh, no, it's in the same region.
Yeah, it's in the same region. But there are other things. A lot of people use Coiled. That one's it feels a lot like Dask Gateway and allows you to pick where the region. So you would want to spin up a virtual machine in the same region, so now you could connect to all that data for free. So in the cloud, now in the cloud world, when we're connecting to data in the cloud, we want to be next to it. All right. So I want to demystify these Docker images a little bit. The basic of a Docker image is something called a Docker file, and that is the instructions. The from, you can think of the from as, hey, what is the base operating system? These two are pretty simple base operating systems. This is just Ubuntu, Linux machine, a Linux operating system. And this one is, you'd have to research this. I bet this is also Ubuntu, and it's got Conda installed. So you tell it the base, and then you give it a bunch of instructions. Say, hey, install all this stuff for me. And that's it. That's kind of it. You don't have to create your Docker image at all. There are lots of really great ones out there. And people make these public. The Pangeo Notebook one is very, very popular for earth science computing. Who gave this talk last year? Patrick Gray. He said that 90% of his work uses the Pangeo Notebook. And then obviously we have the one from the Hack Week here. Okay. And if you want to use somebody else's image, so let's say, so you're going to take, well, okay, I'm just going to show you this. So let's say I want to run this image on my laptop, and I have Docker Desktop installed on my laptop, on my Mac here. So here. This is how easy it is. You have to know the code there that I have there. Zoom. Zoom. Yeah. And I'm saying, hey, run this. I'm telling it, hey, hook up my in my drive, hook up my documents and make that home Javian. Just kind of mount that for me. The ports here, you don't change that. This part is the image that you want. So let's just run that. Oh, really? Okay, well, it was slightly unhappy, but I think it still works. And then it gives you a little URL here. Let's grab it. There we go. Yay, there I am. I have Jupyter Lab. I don't have it installed on this computer, by the way. No, I'm just using the Docker, and it's connected up to my files here. So now with that one command, I have Jupyter Lab, and I have that whole Pangeo environment on my laptop, and I can use it as normal. Okay. And okay, so last demo I want to show is, okay, but what if you did want to create your own Docker image? And as I said, it's gotten a lot easier. And now you can play along if you're so interested. This is the thing I'm going to click. Let's go ahead and click that. So here I have a template repository. And in that, I have a Docker file. So what is this doing? It's saying, hey, use Pangeo Notebook. And I want you to install some more packages. And what are these packages I'm going to install? Well, Pangeo Notebook doesn't have PyObis or CM Ocean, and I'd like to have it. So, so I add those. Okay? And then it has one more bit here, and that is this build and deploy workflow. So GitHub actions are things that are triggered when certain actions happen. and this says, hey, whenever there's a push to the main branch and it's changes to Dockerfile or environment YAML, I want you to do this stuff. Check it out and create the image and host it on GitHub for me. You're going to see that. I'll give you a hint for these GitHub actions. You don't write them from scratch. You find somebody else's, or nowadays you ask AI, write that for me. But they are cool, and you're going to see how it works. So what it's going to do, I'm going to copy this in just a second. It's going to create this image here. So here, you can see there's the address. Does that look kind of familiar? The one we're using is GHCRIO. It's also hosted on GitHub. It is also created with a GitHub action. Okay, so here we go. Here's how you can create your own image. So you say, use this template. So I'm going to put it in my own. Test it. Okay. Great. Just going to take a sec. There we go. It is creating the first version of this image, and it's going to push it. It'll take a few minutes, so I'm just going to get it started, and then we'll come back to it when I'm done in like 2 minutes. So what I've done is I've used this as a template to create my own, but what I want to do is I want to change this a bit. I want to add Earth access, because I know that's not on there. And hopefully, okay, so yeah, okay. So I made it my own. Okay. Look under actions. You can see it's updating that. It's going to finish the first one. I could stop this one if I wanted, but I'll just let this go. And you'll see in a moment, I'm going to have my image, which I can, because it's based on Pangeo Notebook, and Pangeo Notebook will run on Jupyter Hubs, I can use this image immediately in, say, the 2i2c hub. All right. So I just wanted to show you that because it used to be really hard to make these images, but now people have created these GitHub actions, and now we have GitHub where we can host images, and it's so much simpler. You don't have to connect it to Docker Hub. You don't have to like build it on your laptop or anything. It's so much easier. All right, last 2 minutes, and I'll let you get back to your projects. I want to, now I'm switching gears again, talk a little bit about this cloud native science. And I think it was in Kelsey's talk on day 1 or 2, talking about that we're in this renaissance era for earth science. And part of the reason for that is that cloud native science allows us to do things we've never been able to do before. And one of those things has to do with what cloud object storage allows us to do relative to the old ways we used to work. So the old ways, we'd be working on a server. Let's say we had an FTP server. We could have our client. We go to the server, and we grab our file, and we download it, and we work with it. And then we got our like OpenDAP servers, where it's a lot better. We don't have to go and get the whole file, which is important. If the whole file is like a petabyte, we can get a subset. But still, we're going out and we're grabbing that subset. We're either pulling it into memory or we're downloading it onto our computers. And we are limited by the capacity of these servers. They are multi-threaded, which means that multiple clients can connect to them, but it's not infinite. It's limited. And this is different than cloud object storage. The nature, the sort of infrastructure behind cloud object storage, it is designed for the internet. So like when you go to a website, lots and lots of people can go to that website and get the data. It's not like, only 20 can or something like that. Lots and lots. And the cloud object storage is using this technology that allows lots of clients to read the data simultaneously. And for our purposes, it's basically infinite. There are no limits to the number of clients that could connect. And think about Ian's talk yesterday about parallel processing. And now you can see how we're having this rapid increase in the data out there that we could work with. But if we use the old ways that we are working, we just can't do a lot with that. I mean, we're really limited, downloading things and working it there. But when we have things in a cloud native format, and so one of the key things about cloud native is that it's not that it's just up in this object storage, but it's chunked. It's chunked so that we can grab bits of it. And that allows us to do massively parallel computing. And nowadays we have like Xarray that can allow us to do massively parallel computing basically under the hood. And this is how I think of it. We have this problem and we can just set many, many little Dask workers at this petabytes of chunk data in the cloud, and they will grab off those chunks of data. And we're not there yet. There's a whole lot of our data that's still in a legacy formats. It's not yet cloud native, but we're moving rapidly in that direction. And when you hear people talking about, yes, is why it's so important to have the data in cloud native, why there's that big push, and that big push is because of this. We want to be able to work with these petabytes of data, and it needs to be chunked, so we can do that. All right, that's it. 45 minutes. Give you guys 45 more minutes to work on your project.
But first questions.
Oh, yes, first question.
Do we have any questions for Eli about containers, reusable projects, environments?
Hey, thanks for the presentation. That was super interesting and something that's always just so confused me, Docker things especially. So I'm curious if I'm really interested in just building like a Docker image that like mostly just changes kind of Python things. Is that Docker file, is that kind of standard and you just keep it in there, or do you end up having to go in there and alter that a lot too? Does that make sense?
You can have very complicated Docker files. You can tie yourself in knots if you have very complicated Docker files. As you're learning it, you will tie yourself in knots. So, yeah, you can have the Docker file have very, standard like formats, standard ways you do things. Again, it's so wonderful that the AI has been trained on everyone's Docker files, and it does quite well at creating them for you and also solving your errors. And you can basically, it's as if you're writing the file as if you were on the terminal of a virtual machine. Say you did just Ubuntu, right? You are on a de novo, blank slate, and you could install everything that you want to install.
Great, thank you.
Thank you, that was great. In regards to creating a requirements.txt or an environment YAML, is there like a single Python command, or like what's the easiest way to go about making one because I've tried, and I had somebody who's much better at this helping me, and she said, send me your code, I'm just going to make one for you, because it was not going well for me. So is there like a one command that we can run, or like what's the best practice to do that?
Yeah, can somebody who does that answer it? Because I've only written mine just from scratch.
You want to create a requirements file or an environment YAML. Yeah. So there's two ways to do it. The preferred way is to start with a, well, let's talk. You can freeze your current environment. So there are, in both Conda and in Python, there are ways to just say, freeze, give me the list of everything that's currently installed, write that as a requirements file or an environment.yaml, and you've got one. That is maybe more than you wanted because it's everything that's in your current environment. Otherwise, there's different tools for the different ecosystems. I actually don't know for Conda, but for Python, I know a couple tools that maintain a configuration file for you that lists sort of like what you want. So you're like, I want NumPy and Xarray, and then it goes through and says, okay, we're going to lock NumPy and Xarray to a particular version, but then we're also going to lock all of the versions of all those dependencies that those libraries also need. So there are tools for that. One's called UV. It's rapidly becoming the most popular.
I have also learned a lot by going and looking at other environment files. So for example, the default image for the R2I2SE hub is that cryo in the cloud hub image. And you can see theirs is, kind of massive. But it's helpful to like read through and kind of see like, oh, wow, okay, that's all the stuff they're putting in, and kind of think about why they're putting those in. They are using kind of semi-pinned. Yeah, but remember, what Patrick was saying, 90% of his work is on the Pangeo notebook image. And so, yeah, I guess I would think kind of carefully about, why if you need to create your own image, maybe if you're just documenting the environment, you can generate a lock file and save that, and that's the documentation of all the packages that were associated with this project. And that's like one of those things okay, at the end of the big push, okay, I'm bringing the project to completion, and then everything works, I generate the lock file, and that's part of the documentation with this closed project.
I just want to add one asterisk to something that Eli presented. Eli, you showed us we could create an environment in our home directory. Mm-hmm. And you'll also be hearing from me after the course about this 10 gigabyte limit that we're hoping everybody can keep their home directories to. An environment is big, and that will count against your 10 gigabytes. So do that with that awareness.
Yeah, which is why I said don't play along. Don't play along. But for those of you who really need this, it's good to see that it's possible. But yeah, don't leave it on there forever.
You can always create an environment in the temporary space. It's just like Eli said, you have to recreate it every time you start it.
Yeah.
Okay.
I mean, the one limitation is, as you mentioned, it is very slow when we try to create our own environment after we log in. So I just wonder how long it would take, 5 minutes, 10 minutes right now in hours?
We make it faster with a lock file. So Conda takes the most time to solve your environment. If we create a lock file, we skip the solving step. So we solve once, and now we have a file, and now we just tell Conda, install these things. Don't solve anything. And so we can make it down to less than a minute.
If there is a package that you really need on CryoCloud, and that you think that lots of other people probably need it too, you can also put in an issue to CryoCloud and ask them to add it to the image. And I would definitely do that if you think there's like a core image, a core package that they are missing. All right, I'll be here. Feel free to come up and talk with me about Docker images or environments. I create so many images. Okay.